G'day everyone, vector equation of circles. Now we kind of know a bit of work around circles, but probably not in the vector context. So hopefully a few things you already know, that x squared plus y squared equals r squared. Hopefully you're okay with that one. And hopefully you recognise a diagram like this, a circle at the origin and a circle somewhere not at the origin. Okay. Hopefully you recognise that one's going to be that one there. And this one is going to be really x minus a squared plus y minus b squared equals r squared. Now, the a and the b, don't get caught up on those letters. They're just two values to shift it somewhere on the x-axis and shift it somewhere on the y-axis. So don't get hung up on those values. Just recognise that that's the general format of a circle at the origin, a circle not at the origin. Okay. Now let's talk about our vectors. Let's change all that into vector format. Here's my circle, and I've got r being some vector from there to there. Some vector from the centre of the circle, from the origin to the outside. Well, if I take the absolute value of that vector, aren't I really going to take this value, square it, this value, square it, and take the square root of it? And isn't that going to give me a, where a is the radius, right? It's not really a point, it's the radius of it. So if I take the vector that takes me from the centre of the circle to the outside, work out the absolute value of it, that should just give me the radius. Kind of makes sense, doesn't it? Now, if I go a step further and I say, well, let me have r, this vector, and I want to just be this particular one. I want that to be any vector that goes to the circumference. Make r this. So then wouldn't my equation be, oops, like that? All I've done is made that substitution. Now if I work this out, all I get out of that is x squared plus y squared. Now you might think, hang on, no, you missed something. When we expand out brackets like this, you end up with three terms. Now, if you're in your algebra manipulation, I agree. But remember when I would multiply these together, ij multiplied together doesn't make any sense because they're at 90 degrees to each other. So we discard them. I only do this part and this part. The ij part is meaningless. So I only end up with this. Now that also means if I'm going to square the whole thing, then I end up with that there. So this is my vector equation of a circle, and it breaks down to my Cartesian equation of a circle. So they're the same thing. Now over here, when we look at this one, we're at some point. So now r is that line from there to there, and I've got some point D here on the outside of the circle. So couldn't I do this? Absolute value of r minus d. R minus d. Think about that. Minus d would take me from here back to there. Plus r would move me to the centre of the circle. So that distance there is that. When I take the absolute value of it, isn't that just going to give me the distance here? And isn't that going to be equal to, in this case, 2, being the radius of the circle? But I'll just say that equals a for the moment, the radius of the circle. Now, we can go a little bit further with this, and we can say, well, maybe r, let's say r is xi plus yj, right? Just like over here. And maybe d is some point here, so I'm going to call that minus ai minus bj. Now, if I work out the absolute value here, in a similar sort of way, the ij part doesn't make any sense, right? But if I work this out, you'll actually end up with x minus a squared plus y minus b squared equals a squared, which is then the Cartesian equation of this circle anyway. So the vector equation of a circle and the Cartesian equation of the circle, really it's just changing that into that. And over here, a little bit simpler, that's the simplest form of it, and that's the simplest form of it. Hallelujah. There you go. Hopefully this one makes sense. Vector equation of circles. There's not a lot in it once you see where it's actually coming from. Catch you later, guys.